We're solving problem 25 from the 2024 F equals MA exam. A yo-yo consists of two massive uniform discs of radius r connected by a thin axle. A thick string is wrapped many times around the axle so that the end of the string is initially a distance r from the axle. Then, the end of the string is held in place and the yo-yo is dropped from rest. Assume that energy losses are negligible and that the string has negligible mass and always remains vertical. Below, we show a cross-section of the yo-yo partway through its descent. This is about it, roughly where the line wraps around it to the center. And here we have our answer choices. Between the moment and the yo-yo is released and the moment the string completely unwinds, which of the following is true regarding the yo-yo's acceleration? Our answer choices are A, always 0, B, it points downward but decreases in magnitude over time, C, it points downward but has constant magnitude, D, it points downward but increases in magnitude over time, or E, none of the above. Now, our acceleration, it's not always going to be 0 because anything falling has a magnitude of 9.81 meters per second. Without account to its weight. So we know it's not answer choice A because something falling cannot not have gravitational acceleration. Now, let's look at these. Points B, points downward but decreases in magnitude. Well, that would mean that the yo-yo would slow down, and this is not the case because if you've used a yo-yo before, it rolls to the bottom and then gets back up, but when it gets back up, it's only a fraction of the initial height. All these answer choices are pretty weird because we don't really know anything like the specifics and stuff, but we can note that, like, say we have the yo-yo and it's at the very bottom. Like, the string has completely unwinded. So it's been spinning this way, and now it has, it doesn't stop here at this point because all the energy that it gets from spinning this way, the circle, it will spin this way, so like here. And then it'll start climbing back up. So it doesn't really change, or it doesn't stop at a moment because it's going to spin back up at the lowest point. It has velocity going up and the leftward acceleration clockwise now. So our acceleration, it increases at times, but it changes at this point. So rather than all these answer choices only being decreasing, constant, or increasing, it's like a graph with different parts of it, like one part increasing, one part decreasing. Whereas if you say the graph is increasing, that would be wrong. Or if you said it's decreasing, it would also be partially wrong. So therefore, it is answer choice E, none of the above, as our acceleration, it changes at that point.